that some people did not write this in your notes. So in your notes for 11.2, make sure you have written down that the chi-squared is equal to this is I think I had it in here. Hold on. So here you put L2, you put in your observed, L3, you put in your expected, and then in L1, you put in parentheses, L2 minus L3 squared divided by L3. And then your chi-squared is going to equal the sum of the x's for L1. Right? You have to add them all up. Okay, so let's see what people have here. Step 1. I think everybody had step 1 down. O sub I H naught is O sub I equals E sub I. H1 is O sub I is not equal to E sub I pi. All right, so it's fine if you guys are talking, but you should talk quietly, so I should not be able to hear your conversation. You should be quiet, right? And then your critical value, you looked it up on your table, and you ended up getting, I think it was 16 point. Nathan, what was it? 16 point, or Drew, what was it? 16 point what?
812.
16.812.
The screen's off.
Ah, son of a gun. Okay, no worries. We can handle that. There we go. Uh-oh. All right. And then we're going to find our test stat. So you're going to give me this. You're going to say 114 minus 156.4 squared over 156.4 plus 152 minus 156.4 squared over 156.4 plus 160 minus 156.4 squared over 156.4, and let's put a plus, and that's, you wouldn't go more than that, because I'm only going to give you 3 or 4 on the exam. I'm not going to give you that many. I don't expect you to write all 7 of them out. But then you're going to give me, you're going to say that the test set equals, was it 28.9?
29.8.
29.8, because that's way out here. 29.8, so we are going to reject H naught, yeah? Which means that we do have enough evidence to, let's see, here my claim is always going to be 11. My claim is going to be H naught. To reject claim that proportions are as expected. All right, everybody feeling okay about that part? Yes. Okay, so the key thing for here, I think that people got tripped up on was, remember, the expecteds you need to calculate. If they're all equally expected, you take your total and you divide by how many categories you are. There's the same amount in each category. So that's sort of the easy thing, is if the categories are equal, if they're equally likely, then you just take your total, 1095 divide by 7 because there's 7 of them. Divide by whatever your total is. Good. So everybody all right with this part here? Does that make sense, folks? Okay. What I want us to work on next is problem number 1 from our not a study guide. And again, it is not a study guide. All right, so this one right here, scores of 20 games for basketball teams given below. Group frequency distribution for 7 classes. So I want everybody to take 15 seconds and figure out what the class width should be. 30 seconds. 30 seconds. What should the class width be? So what's my class width? Anybody? 10. We want to pick a number that's, whenever possible, we want to pick a 10 or a 5 so that our data is clear and easy to read for people. So that means that the very first number had better be 0 or 1. Does everyone understand that? So I don't care which one you use. I would say ideally 0. So if you already did 1, that's fine. And then find all the rest of these, all your lower class limits, and then find your upper limits. So go do that. Again, if you did 1 instead, that's fine. But you should start with 0 or 1. Keep it easy to understand. Okay, so let's take a look. So first, if I know that my limit is 10, I'll start with my first lower limit of 0, and I'll just keep adding this class limit. 10, 10, 10, 10, 10. Then I go back. What comes before 10? 9. What comes before 20? 19. And you can see a pattern here, right? 29, 39, 49, 59, 69. And we have our frequencies. Relative frequency is how it relates to the whole, the ratio of that frequency to the whole. So the whole is 20, so 1 over 20, 0.05. 2 over 20, 0.1. 0.3, 0.15, 0.2, 0.1, 0.1. Cumulative is how many are in that class or previous class. So that's 1 here. Class or previous class, it's 3 there. 9, 12, 16, 18, 20. All right, then we got our histogram. All right, so the histogram needs to go. All right, so if you're going to use class limits, you can do it using class limits. So I'll just head over here with class limits. I won't do the whole thing, I'll just do part of it. So here I'd go, since I don't have boundaries, I might go like this, just using class limits, 0 to 9. Let's see, that's 1, 2, 3, 4, 5, 6. Would just be right here. And then 10 to 19, that's 2. So I would go just to right there. 20 to 29, that's 6. So we go all the way up here, like that. If you're going to use the class limits, they don't touch, right? Because you stop at 9 and you start again at 10. You could also do the boundaries. That's another possibility. If you do the boundaries, then I'd go, 0, and then I'd go 9.5, 19.5, 29.5. And then these would touch. 1, 2, 3, 4, 5, 6, The first one would be 1. The next one would go to 2. The next one goes all the way up to 6. Like that. So if you use the boundaries, then they would touch. So everybody good, either one or the other. I don't care which one you use. But everybody's comfortable with the one they're using? Great. Then let's go ahead and skip over to problem number 13. Right there. Broccoli. And are they independent? Test for independence. In chapter 11, our test of independence is the same thing as proportions being equal. So when the proportions are equal. The question is what proportions, I suppose. All right, let's go over this one. So first of all, probability someone likes broccoli. Well, likes broccoli, that's 51 out of 100. There's 51 people like broccoli out of 100. Man or child? Well, there's 38 men, there's 22 children, so 38 plus 22 out of 100. That's 60 over 100. Next one is child or likes broccoli. Okay, so there's 22 children and 51 people who like broccoli, so it's 22 plus 51. However, there are these 10 kids who are in both groups. They're double counted, so you have to subtract out those 10 because they're getting counted twice. And so she'll only be counted once. Out of 100, that ends up being 63 out of 100. Dislikes broccoli and is a man. So how many men dislike broccoli? Well, 17 men like broccoli, 21 of them dislike broccoli. So 21 men dislike broccoli, so 21 out of 100. That that you dislike broccoli and you're a man, that you're both. Does that make sense to folks? Okay. Now, likes broccoli given they're a woman. Given they're a woman means that you are definitely a woman, 100%. So that means that 100% you are in this group. Ooh, sorry, I didn't mean to do that. I meant to do it. 100% you are in this group. What's the probability that you like broccoli? 24 out of 40. Given is the only time that is not out of everybody's. And remember, everyone look up. See this division, this given symbol? It looks kind of like a division sign. You're dividing by the number of women. Right? So the broccoli lovers, broccoli women divided by the number of women. So you're dividing by 40. So this is going to be 24 out of 40. And the last one is likes broccoli and women independent or dependent. So for that one, you need to circle all the things that have to do with broccoli and women. Quiet, you guys. Broccoli and women. So broccoli women, total broccoli, and grand total. Those are my ratios. So it's going to be, the question becomes, is 24 over 40 the same as 51 over 100? And that is not equal, so that means that they're dependent. Because remember, equal proportions means they're independent. Proportions are not equal, so they're dependent. You have to do that ratio. That might be the hardest one, just as a good reminder. Now everyone take a look at number 14 below it. That is your homework to get done before next class. You can start it now. A lot of you folks have already started it. If you have not finished it, finish it before class. We're going to go over it next class. Hold up. Whoa, wait. I still have a minute. Stop. Come back. Okay, so here we have red marbles, blue marbles, green marbles. What if I draw a marble? What's my first? What can I possibly get?
Red marble.
Red, blue, or green. How many are red? 2 out of how many? 11. 2 out of 11. So that's my first probability. You have to find the rest of them. My second draw, what could I draw? Also red, blue, or green. But remember, I'm keeping a marble. I'm not replacing it. So it's got, these probabilities are going to change for the second drop. Okay, so, yeah, now class is over. So go ahead and work on, if you haven't finished working on this one, if you haven't done it yet, make sure you get it done before class on Thursday. We're going to go over it then.